notes 5.4. Okay, for a little review, this is the exponential function, y equals a to the x. Okay, is it 1 to 1? Okay, if you remember this graph, if a is greater than 1, it's growth, or if it's between 0 and 1, it would be decay. But it is 1 to 1. Okay, it passes the horizontal line test, and so therefore it does have an inverse. Okay, so let's see what the inverse is. So the inverse, okay, for the inverse I'm going to switch the x and the y, right? So this y becomes x equals a to the y. Okay, now if I want to solve for y, can I get y by itself now? If I change this to a log function, okay, it'd be log base a of x equals y. So this is the inverse. Okay, so the exponential and the log function are inverses of each other. The graph of the log function will look like this. They are reflections across this line, y equal x. Okay, so what we're going to do today is we're going to look at what these log functions look like. Okay, if you think about this one here, remember how we had a asymptote right here? Well, the log functions just switch to the x and the y, right? So the asymptote's going to be there instead. So we'll look at some of these things here. Okay, if you remember the other day, y is equal to 2 to the x. We made a table of values, right? An x and a y. So 2 to the x, we used like -2, -1, 0, 1, 2, and we plotted those. So this was 1/4, 1/2, 1, and 2, and 2 squared is 4. Okay, so we looked at that graph, and if we plot those points, it was a graph that looked like this. Okay, now the inverse one, okay, so that we know this is the inverse of it. So if I take these, and I can just switch the x and the y. So we can use 1/4 -2, 1/2 -1, 1 0, 2 1, and 4 2. Okay, so we just plot those points. So 1/4 -2, okay, 1/2 -1, okay, 1 0, 2 1, and 4 2, and we get a graph that looks like this. Okay, so if you think about this, okay, so domain, range, and asymptote. Okay, so for this one here, our domain here goes, for the blue, goes all real numbers. And my range, remember there's an asymptote right here at 0, so it's above 0. So y has to be greater than 0. And the asymptote is at y equals 0. Okay, now for the log function, the red one, our domain starts here at 0 and greater. So x has to be greater than 0. And the range is going to go all the way down, and it's going to go all the way up, so it'll be all real numbers. Notice it's just switching the x and the y, right? Same with the asymptote. Instead of being at y equals 0, we have an asymptote at x equals 0. The other way you could graph is to change this equation and put it into an exponential form. It'd be the base raised to the outside part equals the inside part. And then you could just take some values and plug them in here. Now it'd be easier to plug them in for the y to see what the x is, right? So we're going to kind of work backwards. So if I plug a 1, 2, 3 for your y's, right? 2 to the first power, anything to the right, is 2. 2 to the second power is 4. 2 to the third power is 8. And then you can also use some 0 and negative, right? Anything to 0 power is 1, and be 1/2. So that's another way you could get these points that we have here to plot. Okay, but yeah, same method there. Found domain, range, and asymptote. Okay, so pause the video and try this one yourself. Okay, now it's 1/2 to the x. Okay, so you know it's now not exponential growth, decay sort of idea. So you can think about that. Okay, so method 1 is to take the inverse of this, which would be y is equal to 1/2 to the x. Okay, and find values, right? Okay, so plug in -2, you get 4, -1, you get 2, anything to 0 power is 1, half to the 1 is 1/2, and be 1/4. Okay, so you remember this one, it goes like this. Okay, so there's that function. Now to find the actual inverse, okay, to find this one, the inverse of that, which is this, we can just switch the x and the y of this one. So 4, -2, 2, -1, 1, 0, 1/2, 1, 1/4, 2. Okay, so when you plot those, you get the same thing there. It will look like this. So that point gets reflected there, this point gets reflected over there, etc. Okay, so we think about of the blue, the domain, the range, and the asymptote. So domain of the blue one, all real numbers. The range, we have an asymptote here at 0, so up, so it'd be y is greater than 0, and the asymptote is at y equals 0. Now for the red one, our domain, okay, doesn't go past 0 here, so it's from 0 through infinity. So x has to be greater than 0. The y's go up, y's go down, so y is all real numbers, and the asymptote is now right here at y x equals 0. Okay. The other method was to find points. You could just take this and put it into so this would be into an exponential form. So it'd be 1/2 to the y equals x, and then just pick some values for your y. Okay, -1, 0, 1, 2, 3. Okay, pick some y. So 1/2 to the -1 would be 2. Anything to 0 power is 1. 1/2 to the 1 is 1/2. 1/2 squared would be 1/4, and 1/8. So you can plot those to get that same graph there. Okay, next one's here. We want to look at what transformations do. Same as the stuff that we've done in the past. Same as like if it's like x plus 2 squared, right? Remember how we moved that left 2? And if it'd be x squared plus 2, we know how it moved up 2. Okay, same sort of idea here. So we take our basic function, okay, basic log function. This changes the steepness of it, but this still is the major things are still the same. Okay, so if it's -1 on the inside, it actually moves over 1. So instead of being right here, okay, it's going to go instead of going through 1 there, it's going to go through 1 here. So it'll look something like this. I'm sorry, it's growth, not decay. Okay, so instead of going through here at 1, it's going to go over here at 1, so it's shifted over to the right one. Okay, so that'd be our graph there. And if we have, that's just kind of the steepness, but we're still going to look at that 1 and see where it shifts. So it's going to go down 1, so instead of here, it's here. And the asymptote, instead of being there, would being shifted down 1. So we now have the graph that looks like this. Okay, you can always use Desmos to kind of look at it and make sure you understand it and stuff. But let's go through and look at the domain for these. Domain, all real numbers. Domain, once again, still all real numbers. I'm sorry, I am wrong. I took this as exponential, didn't I? It's not an exponential though. I got my wrong parent function. Okay, let me start over here. With the log of x, right, our function looks like this. Log function, not exponential, log. Okay, so this is just being shifted to the right one, still right one. Okay, so instead of the asymptote being here, my asymptote is going to be at 1. So my graph would look like this. And here, taking this function and it's being shifted down 1. So instead of going through at 1 here, it's going to go through at 1 down there. So basic same I think, just kind of shifted down 1. Alright, so domain, okay, So we have this asymptote here, right? So our x's have to be greater than 1. And here our asymptote's still at 0, so x has to be greater than 0. Our range, all up, all down, so both of those are all real numbers. Our asymptote here, it got shifted to the right one, so it's at x equals 1. Here it's still at x equals 0. Okay, our x-intercept, usually our x-intercept is here at 1, but it got shifted this way 1, so it's actually at 2. This one here, this x-intercept, a little bit harder to do, just because it's going to be some sort of decimal there. You can find it on Desmos if you want to, but yeah. Is it increasing or decreasing? Both of these are increasing. Symmetry doesn't really have any symmetry here. We're going to see some symmetry things in these next two, though. Okay. For these last two here, I would just put it in Desmos for you to get a graph. But you know that absolute value kind of makes a V, right? Because it's the positive and the negative sort of negatives turn to positive. So what you do is your graph will look like this. Okay. We'll still have an asymptote right here, but we have it true on both sides. Okay, so the domain would be all real numbers, but the x cannot equal 0. We still have an asymptote here. Our range would be all up and all down, so that'd still be all real numbers. Our asymptote here would still be at x equals 1. For here it's decreasing and here it's increasing. Okay, so it's increasing from negative infinity to 0, and it's decreasing, I'm sorry, that's the decreasing part, and it's increasing from 0 through infinity. Okay, it's not doing anything at 0, that's why I'd have the bracket, the parentheses versus the brackets. Okay, is there symmetry? Yes, across the line, across the y-axis. Okay. If we look at this one, okay, once again you can type this in on Desmos, and the graph looks, there's actually two asymptotes at 2 and negative 2, because if you set this equal to 0 and solve it right, you get 2 and negative 2, and you would get a graph that looks like this. Anyway, something like that. Okay. So our domain. Okay, so we have domain that is from negative infinity to negative 2, and then from 2 through infinity as well, so down here and up here. Our range goes up and down, so that's all real numbers. We have two asymptotes, at x equals negative 2 and at 2. X-intercepts, you could find that on Desmos just by clicking on them. We're not going to worry about that one in this problem. It is decreasing on this part, and that's from negative infinity to negative 2, and it's increasing from here 2 to infinity. Okay, and there is symmetry across your y-axis again. Okay, so we have some symmetry with those. Okay, last problem here we want to work on. It says find the inverse of this equation. Okay, so once again, to find the inverse, we want to switch the x and the y. So, and then we want to learn to solve for that y, right? So to solve for that y, I'm going to subtract that 3 over. I'm going to divide by the negative 1. And then I can use that log function, right? So I can say log base 2 of negative x plus 3 equals the y. So there I have solved for the y. I found the inverse for it.